Hello everyone, this is Puya. In this video, I want to show you three different methods to reverse a linked list. One recursive method and two non-recursive methods. Let's start with the recursive method. So let's assume that the head pointer that we have pointing to the linked list, it's a global variable. So like for this one, I want to show you different versions of how this function can be written. So in the first one, I assume that the head is a global variable. Okay, so we assume that we have a node star head pointer defined as a global variable in this case. Okay, so, and we want to write a recursive function. Let's call it reverse. That would take the head pointer, I'm just going to call it P, and it would reverse the function, right? So because I assume that the head pointer is global, I can write this as a void function. If it was not a global variable, right, then I had to return the final head pointer. In the non-recursive method that I'm going to write a function for, I'm going to do it differently so that you see both versions. Okay, so basically what happens now is in the function, we're going to have another pointer that's going to point to the first node, the head node, right? So what we want to do, we want to move this pointer all the way to the end and start reversing the pointers and like make this node, which is the tail node, the head of the linked list, and the original head node would become the tail of the linked list. So what we want to do, we want to have something like this. We want to basically traverse through the linked list. So I'm going to call the same function, right? I'm going to call the same function, but every time I'm going to move the head pointer, like, let me write it like differently. So I'm going to write it like this, then this, then this. Okay, so once we get to this point, we can't go any further. So we need, this is going to be our base case. This is going to be our stopping criteria, right? So once we get to the point that P arrow next the next is the pointer part of the node. If P arrow next is equal null pointer or null, let's write null pointer. You can write null pointer or 0, right? Null pointer is the recommended version of writing. If this is the case, right, then this is going to become our head of the linked list. So I want to change head to become P and return. We are done. Okay, return. Right. I can do this because head is defined as the global variable. So whatever change I make to the head is going to be permanent. If this wasn't the case, I had to write this one returning node star, and I would return the head. Okay, we're going to see this in the different version that I'm going to write. So this is what we have. So once we have our P at this point, right, then this becomes the head of the linked list, right? This is not head anymore. Okay, right? And then we return. Where do we return? We return to the previous function call, where P was pointing to the second last node. Okay, so this is what we have right now, right? This is done, right? We came back from the function that the function call that where P was pointing to the last node. We changed the head, and now that we have returned from it, it can continue, right? So we are at the point that P is pointing to the second last node here, right? What we want to do, we want to make this pointer point to this node, right? And we want to remove this connection. We want to remove this pointer pointing to the last node. So what we can do, I'm going to define another pointer. I'm going to say node star Q is equal to P arrow next. So what's going to happen now, we're going to have this new pointer Q, which is going to be equal to P arrow next. This is P arrow next. This is where P is pointing to, right? Can you guys see the whole whiteboard? Yeah. So this is where P is pointing to. This is P arrow next. P arrow next is pointing to this node. Q is equal to P arrow next. So it means that Q is going to point to the same node. Okay. Now, if I want to move this one, if I want to make this pointer point to this one, I can do that, right? This is the reason I defined this like this. So how can I make this pointer point to the node that P is pointing to? Can you guys tell me or guess how this is done? What is this node? It's Q arrow next, right? You might think that, okay, this is also head arrow next, but why am I not using this one? Because I want to write a program that would work for other nodes as well, not only for the last node. Okay, so I'm going to say Q arrow next is equal to, I want this pointer to point to this node. Do I have a pointer pointing to this node? Yes, I do. It's P. So I'm going to say Q arrow next is equal to P, right? So this pointer has been reserved in the stack, in the call stack, in the stack frame of the function. So we already have it once we return from this one, right? So what's gonna happen now? This is gonna point to this node, okay? And I can also remove this one. I'm gonna say that P, I don't need this connection anymore. So I can say that P arrow next is equal to null, right? You might think that this is not going to be very like it's not going to be very necessary at this point, right? But we write this one so that once we get to the end of the linked list from this side, this is going to be taken care of. Okay, so we did one node. This is like what we wanted to do. Okay, so now the function is going to return. We got to the end of the function. The function is going to return. It's going to return to the point that the function was called. Where was the function called? It was called at the point that P was pointing to this node, the previous node. So it's going to come back here. It's going to continue. It's going to say node. So again, like this Q is going to be deallocated once we return from the function. We're going to have another Q, which is going to point to P arrow, where P arrow next is pointing to. And again, we say that Q arrow next, which is this one, let's make this one point to where P is pointing to. And P arrow next becomes null. We got to the end of the function. We can return. We're going to return to the point, to the function call that where P was pointing to this node, which is happened to be the head of the linked list. So this is done. It's gonna say, okay, again, like this was deallocated, we're gonna have a new queue. Q is equal to P arrow next. This is P arrow next. It's pointing to this node, so Q is gonna point to the same node. Excuse me, Q arrow next is equal to P. This is gonna point to this one. Okay, and say P arrow next is equal to null. So this is not the case anymore. This becomes null. You can write this one null pointer as well. And we are done. This was the first time the function was called. Right? So this is the first function call. We are done. And you can see that the head is now pointing to the tail of the original linked list. And we have reversed the linked list. So this is the first version of writing this function. It's a recursive function. As I mentioned, you can assume that this is not a global variable, and then in that case, you can return the head, right? So you can just like change the function so that you can return the head, but that's basically what this is. So this is done. I hope this makes sense. So like we have reversed the linked list recursively. This is one version of writing the problem. Solving the problem, sorry. Okay, so I'm gonna go back to what we had before. This is head. Sorry. This is not null. This is pointing to here. This is pointing to here. This is pointing to here. This is null. Okay. I've also like the blue numbers I have written here. They're just random addresses that I have put for the nodes, right? The 0x is the notation for hexadecimal base, and the addresses are usually displayed in the hexadecimal base. And well, like here, like I'm using an 8-bit format, but it can be 32-bit or 64-bit, or like in different systems. Now we want to write the same function, but this time non-recursively. Okay, so I'm gonna write the same function reverse. We still gonna take the head pointer. Okay, this time I'm gonna assume that this is not a global variable, so that you see the different version of it as well. So I'm gonna return the node star. So once this is done, I have to return the new head of the linked list. Okay, so we did this in the linked list video, but I'm gonna do it one more time so that you see this, and hopefully you can compare it with other methods. So once we go here, we have to be careful. We don't want to change this one because we can change this one, sorry. We can change this one, right? But we have to know that we have to return the final head, which is going to be ideally pointing, like if you write the program correctly, it's going to be pointing to the last node. Okay, so I want to traverse through the linked list all the way to the end, right? And just reverse these pointers, okay? So like for doing that, I want to make sure that I'm not gonna, like once I traverse, I want to have access to the next node and the previous node. So what I'm gonna do, I'm gonna write three pointers. Let's first call this one current, and I'm gonna initialize it with head. I'm gonna have another one. Let's call this one previous, and I'm gonna initialize this with null. And another one which is gonna be called next. I'm not gonna initialize it here. Okay, and what I want to do, so like let's draw these pointers. So this is C current, which is going to be pointing to where head is pointing to, previous, which is null, and next, which hasn't been initialized yet. Okay, so what I want to do, I want to write a loop that would traverse through the linked list. So what I want to have, let me write a while loop. I'm just gonna open and close brackets like this. Okay, and what I want to do, it's just basically saying that, okay, while I haven't got to the end of the linked list, so while C is not equal to null, right? So you just like, you move C here, C here, C here, and then finally C becomes equal to null, right? So while I haven't got to that point, still stay in the loop. Okay, you saw that in the recursive version we didn't have a loop. The loop was implicit in the recursion. But here what we do now, each time we're gonna say, okay, at this point now I can initialize. Once I go here, I can initialize the next node. So I want this pointer to point where the next node is. So I'm gonna write C arrow next. Okay. How about current? So I'm gonna say that, so like now like I can change this one, because now I have a pointer pointing to this, right? I don't need this pointer anymore, right? I needed this pointer so that I can go to this one. I don't need it anymore. So now I can say that C arrow next is equal to previous. Right, so what's gonna happen? This, which is C arrow next, is gonna become null. Okay, and then what's the next step? I'm gonna say that, okay, now like I wanna like move these ones, right? So I wanna say that now my previous is gonna become this one and my current is gonna become this one. So I'm gonna say that now this is done. Whatever I wanted to do to this node is done. Like I don't need this anymore. So I'm gonna say P is equal to C. So this is not null anymore. It's gonna point to here. And C is equal to N. So C is equal to N. So this is gonna point here. So we did one iteration in the loop, right? Now C is pointing here. Next is also pointing here. Previous is pointing to the previous node. So once we go here, it says N is equal to C arrow next, right? So like I always want to have a pointer to the next node. So this is gonna point to this node. It says C arrow next, current arrow next, right? I don't need this pointer anymore. This is gonna point to where previous is pointing to, right? This is what I wanted to do. So I'm doing it one at a time, one node at a time. I did this node, now I'm doing this node. Okay, now I'm done with this node. So my previous is now becoming the next node, and my current is gonna point to the next node. Second iteration is done. We go inside the loop again. It's gonna come back here. It says N is equal to C arrow next. So N is not pointing here, N is pointing here. Okay, and what do we do now? C arrow next, again, this is not pointing to this node. C arrow next is pointing where P is pointing to, which is pointing to this node. Okay. We are again also done with this node. We don't need like to do any other alteration to this node, modification to this node. So what we do, we just move P and C again. So P is pointing to where C is pointing to, and current is gonna point to where next is pointing to. So this iteration is also done. We're gonna come back here. Next is equal to current arrow next. So next becomes, what does it become? Current arrow next is null, so this becomes 0 or null. And current arrow next becomes equal to P, so it means that this pointer is going to point to this node, right? Previous is equal to current. Again, we are done with this node, so previous is equal to current, and current is equal to next. So current becomes also, at this point, current becomes null or 0. We come back here, we have to check the condition. This condition is not true anymore. Okay, this condition is not true anymore. Are we done? So can I just like leave the function like this? Look at this one. First of all, we have to return a node pointer. Okay. Also, did we change the head? No. Right? So what I need to do I have any pointer pointing to the new head of the linked list? I do. Right? So I'm gonna say that head is equal to P. So this is not gonna be head anymore. Head is gonna be pointing where P is pointing to, and I'm just gonna return head. Or I could just like write return P. That would have been okay too. Okay. So this is the second version of writing this program, this function. This is non-recursive version of reversing a linked list. Okay, so we use like 3 different pointers: current, previous, and next, to keep track of like the pointers that need to point to the previous nodes and the next nodes. Okay, so this was needed to do like everything that we did in the loop. Okay, so this is another version of the same program. We only have one function call, right? So like there's no like sequence of call stacks or like stack frames. So like everything is done in one function call. Okay, so in that case, it's more time efficient. Okay, I hope that makes sense. And just like again, like I want to point out this difference between this version and the previous version. In the previous version, I assume that the head pointer is global, right? So I just like, it was a void function, and I changed the head in the function here. Like even if I don't change this one and return P, that would have been okay too, because all of them are local variables. It doesn't matter. Okay, so this is also done. This is the second version of writing this function. Sorry for wasting your time, but I just have to do this one more time. This is null. I'm gonna write the addresses one more time: 0xb0, 0xc0, 0xd0, and these are the data for the 0, and it's just like have a head pointer pointing to the head of the linked list. Okay, so now let's look at another version of writing the same code. This one is also a non-recursive solution. Okay, this time I want to use the concept of stack. Okay, so we want to use the concept of stack to do this. So this is going to be a good review of both linked list and the stacks. So let's write down functions. So like I don't have enough space, so like I'm not gonna write the header of the function, everything, but just like I'm gonna write a pseudocode here. So at this point, first of all, we need to have like, maybe I should have done this in the previous ones as well, but like if head is equal to null, do we have to do anything? Right? If we have an empty linked list, no. So at this point, return. Okay, and what we do, now we're gonna make a stack. Stack of what? Let me write down this one, stack. So let's assume that I'm using a templated class of stacks. Let's call this one S. Can you guys tell me like why, or like think about this one, like what is the data type that's gonna be stored in this stack? It's gonna be a pointer to node, right? It's not node itself. I'm not gonna stack the nodes. I'm gonna store the pointers. Like what is the pointer hold? It basically holds the addresses of the nodes. Okay, so let's see how this one is gonna work. So similar to what we did previously, we're gonna have, let's say, node star current equal to head. Okay, so we're gonna have another pointer pointing to where head is pointing to. Okay, so what I want to do, I want to save all the addresses of these nodes in this stack. Okay, so first of all, let me tell you this, that this is not a very efficient method to do this. I'm just going to do this as a practice so that you see an application of stacks. You see why this is not efficient, because first of all, we're going to have like a separate part of the memory stored for something other than our linked list. So you're using extra memory. We're also like doing copying into the stack and then popping the stack back. So it's not going to be very efficient, but it's a very good exercise to see both like how to work with linked lists and stacks. So we'll say that like we want to traverse through this linked list. So again, I'm going to write a while loop, and I'm going to say while C is not equal to null or null pointer, okay, traverse through the linked list. Okay, and what I'm gonna do, just like this is like how I'm gonna traverse through the linked list. C is equal to C arrow next. Right, so I'm gonna move this one until C becomes the null pointer. Let me write this one null as well so that we don't get confused. Okay, and every time I do that, I wanna store whatever the address of the linked list is in the stack. Okay, so I'm gonna write s dot push C. Is C a node star? Yes, it is. Right, what is inside C? It's the address of the pointer, the node that it is pointing to. So like here at this point inside C, like you would have 0xA0. So once you push this, this is the top of the stack. So it's gonna go here. This is becoming 0xA0. 0, right? Then C is gonna point to this one. We're gonna stack 0x B0. Then it's gonna go here, it's gonna become 0x C0. Then it goes to the last one, 0x D0, and finally becomes null. At this point, we're done with this loop. Okay, we're done with this loop. We don't need to do anything else. Okay, so we wrote one loop only to push all the addresses of the nodes into our stack. This is our stack. Let's call it, that has a name S. So now what we need to do, right? We didn't do any work of what we needed to do, right? Now, but I have all the addresses in the order that I want, right? You see that, like, this is gonna be the last one, this is gonna be the second last one, the third last one, and finally the first one. Okay, so what I'm gonna say is, like, now I want this current pointer to point to the beginning of the linked list, the end of the linked list. So I'm gonna write that C is equal to, do I have this? Yes, I do, right? So I'm gonna say that, okay, give me the top of my stack. Okay, so now C is gonna point here, right? 0x D0. Okay, and I can also know that, like, at this point, once I get to this one, right, I don't want the head to be here, so I'm gonna say head is also equal to C. So this is also my head. I'm not gonna change head after this, right? This is what we have, right? And we are done with this node. Almost. We are almost done with this node. Okay, so what I need to do now, what I need to do now is just, like, basically pop the rest of, like, or pop the rest of them. Okay, so I said that C is equal to S dot top, that's it, right? And head is equal to T, right? And now let me just, like, say that S dot pop. So this is popped from the stack. Okay, I don't need this address anymore. I have it inside C. Okay, and now I'm just gonna continue writing the program here. Let me just, so this is gonna be the continuation of the program. I'm gonna say while I still have some addresses in the stack, while I haven't popped everything in the stack. So what should I write? While let me say, like, let's say, like, not s dot empty. We have an empty member function in the class of a stack that will return true once the stack becomes empty. So while we still have something in the stack, just continue this. Okay, now what do I want to do first? I want to make sure that this is going to be pointing to here. Okay, so I'm going to write this one. C arrow next is equal to, I want C arrow next, which is this one. I want to store this address inside here. Can I do that? Do I have this address? Yes, I do. I have it on the top of the stack. So I'm going to say s dot top. Once I do that, this is going to become, I'm just going to write the address here so that you see this. This becomes 0xC0, and this is going to point here. Okay. And now I'm done with this one. I don't need it anymore because I have stored it in this pointer. So I can say that s dot pop. remove this one from my stack. I don't need it anymore. Okay, right? And then I want to traverse the C into this direction towards the left. Can I do that? Yes, now that I have this pointer pointing to this node, I can write C is equal to C arrow next. So C is gonna, this is not gonna be D0, it's gonna become C0, so it's gonna point to this one. We come back to the beginning of the linked list. C arrow next, which is this one, is gonna be S dot top, so it becomes 0xB0. Pop, so this is actually pointing here. Pop it, we popped it. C is equal to C arrow next, so this becomes 0xB0. This is going to point to here. Come back to the beginning of the linked list. Stack is not empty yet. So C arrow next, which is this one, is equal to S dot top, which is going to be 0xA0. So this is going to point to this node. Okay. And pop the last element. And C is equal to C arrow next. So this is going to come point to this one. Okay, and now we come back here. We have to check the condition. Are we done? Yes, we are done with this loop because now our stack is empty. Okay, so this is the end of the loop. Are we done with our program though? There's one thing missing. You see that I have the head pointer pointing here. I have this pointer correctly pointing to this one. This one is okay. This one is okay. But look at this. What should this one be? It should be null, right? So this is what's missing, and we can do it outside the loop. We can say that C arrow next, I have a pointer pointing to this node. I can say C arrow next is equal to, what should I write? Null pointer. So this is also becoming null, and we are done. So this is how we can reverse a linked list. I showed you 3 different versions of it. The first one was a recursive version. The second and third one were non-recursive. And in the last one, I showed you using stack to do reversion for us. Again, like this is not especially memory efficient because we are using, if we have n nodes, we are using n like spaces, n node spaces, node memory sizes for like storing the stacks elements, right? And also like we have 2 loops, one loop for pushing stuff into the stack, pushing the addresses into the stack, and another one for popping them, right? So you can compare the time efficiency and complexity of these nodes. In terms of like programmer effort, maybe the recursive one or this one like might be easier to write for the programmer, but in terms of efficiency, the second one, it's more time efficient and memory efficient compared to the other 2, because like we only had 1 loop, we didn't use extra memory space, and so it was pretty efficient, but it was a little bit complicated. Like you had to think about the algorithm, and like you had to like define extra pointer variables, previous and next pointer variables to do the traversing. Okay, I hope this makes sense. Thank you so much. Bye for now.